in this another video in discrete mathematics, as I am discussing the important topics from your exam point of view. So in that series today I am going to teach you about the logical equivalence. These are the laws as we have heard about in some computer subjects who have already done BCA and pursuing MCA and okay in already in your schools, right? Like if I name them some laws: identity laws, domination laws, idempotent laws, commutative, associative, distributive, Demorgans laws or theorem, absorption laws and negation laws. So let's study each law one by one. So first law is your identity law. Identity law says that if there is a preposition P and it is in conjunction with T, right? So it will be equivalence to P. Okay, and if there is a preposition P and which is disjunctive to F, then the equivalence will be what? P, right? So these are known as identity laws. If you prove it, so let's on the left hand side you can put a value because it is a preposition and it can take two values only, true or false. So if I put true first, then true and true conjunction with true, it is true, because if you remember my last lecture, I just told you that in conjunction, if both prepositions P and Q are true, then it is true, otherwise false. So if I take F here in place of T, then and T, it will be evaluated to false. So that means the P, because these two values are with P, so P and T and P and T will be P. Okay, so that's why this equivalence or this is true, hence it is proved. If they ask you in your exams that prove this identity law or prove this equivalence, as they can ask you, because many times they have asked the direct questions and based on these laws or to prove these laws. So in that way you can prove this law P disjunction and F will P, because if I took the value of P is first as true, so true read as disjunction or F will be true, because it's one of the statement of one of the preposition is true, so it will be evaluated to true. And if you say here P is false, so false disjunction false will be false. So that's why again it is proved that these two equivalents are true, and which they are. So I'm just giving you proof that you can also verify by putting the values, different values of P. Obviously, because P is a proposition and it can take only two values, either true or false. So this is your identity law. Likewise, we have another law which is known as domination law. Dominate से मिलके बना है domination law, right? So domination laws says if there is a proposition P and it is disjunctive or disjunction with F, then it will be evaluated to, right, what? F. P or F. Okay, we have already covered the identity law. Sorry for that. Let me read this. So P or true, right? T will be true, right? And P and F will be false. Again, you can prove them by putting the values of P. Once you can take P as true, so true or true will be true, because if either of the value is true, then it will be true, right? And if you take P as F, then it will be again F, or true will be true because one of the values is true. So in that way you can prove these domination laws. And again, for this you can take the different values of P, either true or false, and then because it is in conjunction with this statement which is always false, so it will be false, because as we know that in conjunction, if both the prepositions are true, then it will be true, otherwise it will be false. So, and it cannot be true all the time, because it is for one of the prepositions of a statement is false. So that's why it is proved. Okay, now we look for another law which is very much important, idempotent law. Okay, idempotent law. And this law says that if we disjunct with P or P, then it will be P, and if we take P conjunction with P, then it will be P. So again, you can put the values. If I take true, P is true, so true or true will be true, false or false will be false, obviously, because both the statements are false or both the prepositions are false. And P and P is P. If I take true, the true and true, or true conjunction with true is true. I'm saying and or because in digital electronics this denotes OR gate, and this conjunction denotes AND gate. So that's why I'm saying or AND for conjunction and disjunction, which is fine because here we have true false, and in electronics they have 0 and 1. Okay. Now come back to another law, which is commutative law. Commutative law is a law in which if I take P or Q, it will be equivalence to Q or P, right? And if I take P and or conjunction with Q, it will be like Q and conjunction with P, right? And which is again self-explanatory, because if I took the values, let's say P is true and Q is true, so P true or true will be true, and then the values will be same, so true or true will be same, so they are same, right? Now take another law, which is associative law, right? Associative law. And associative law is the association between some statements, right? If I take this P or Q or R, and it will be equivalence to, because this sign, because three symbols like this, it denotes the equivalence, and double is equal to, right? And we know that. So in that case, this P or Q or R is associated with, if I take this P or and Q or R or disjunction with R, so it will be same. Again, for the case when we have conjunction with P and P conjunction with Q, R will be equivalence to, by taking these two groups of these propositions Q or R, right? So this will be equal, right? You can verify it by taking the taking the values for P or Q and R, right? Now now we have the Demorgan's Law, or we also know it as Demorgan's theorem, right? Demorgan's Law, which is again a very important law when we solve these equivalence or this type of prepositions to prove or disprove a statement. So Demorgan's law says that if I take negation of this disjunction, then it will be equivalence to not P not Q, and this disjunction will be changed to and for the another case of this, P conjunction with Q will be equivalence to not P not Q, and this symbol will change to this symbol. So this is the very important topic, and this is very important law. So you must understand this and must remember this. It's very easy because we are taking the negation of this whole statement, and then this negation is will be to the individual prepositions, and the conjunction will be changed to disjunction, and disjunction will be changed to the conjunction, right? Now we have absorption law, right? Absorption law, which is again very important, and you must remember these laws, right? You must remember these laws because they are very much important from exam point of view, right? So if I have this kind of a statement, P or P, right? P or P and Q, it will be equivalence to P. You can again verify it by putting the values of P and Q, and then prove it by putting the values of P and Q, and then with solving these statements, and the last truth table will be your P, right? So the truth table for P and for this statement will be equivalence, right? So now P and P or Q, again this will be equivalence to P, right? And you can prove it. How can we prove it? By taking the combinations of true and false for P and Q. And if you want that I must prove it for you, then you can leave a message or leave a comment in comment sections, okay? So I will make a separate video to prove some statements or examples that are asked in your previous year papers, right? So I will took the examples from there, and I have already discussed some of the papers in this discrete mathematics playlist. Now come to the next law, which is your negation law. Negation law is again a very important, because the negation of preposition will be again that preposition. If I took the okay, negation law is right. If P or not P will be true, and P and not P will be false, because if I took, in this case, if I took the values for P as true, so true or, then it will be false because it is negation. So true or false will be true, because in disjunction we know that if one of the statement, if one of the input or if one of the preposition is true, then it is true, right? So this is the equivalence symbol, because these two are equivalence. So this is all about the negation law. Now the last law which I have left is distributive law, right? So distributive law is again very easy, right? Distributive law. Distributive law says if we have this kind of formation of these prepositions like P or Q or R, okay, so in that case P or Q, P or Q and R. So this if this type of statement we have, so in that case the or this I am saying or again, so this conjunction, okay, this disjunction will be distributed to these two statements. So P or Q, which is disjunction, P or Q and P or R. Okay, so this is the distributive law. If I take the next variation of this law, so by just replacing these symbols for conjunction and disjunction, so in this case when this disjunction or was distributed to this and this, and in that case this symbol which is of conjunction will be distributed over Q and R. So P disjunction Q or P disjunction R, right? So this is your distributive law. So again these laws are very much important, so to keep in mind these laws, and if you don't want to forget these laws, so you have to prove them by yourself by putting the values for P and Q and R. So again, if you don't know that how to put the values for P, Q and R, so if we have only two prepositions P, Q, so there will be four combinations of true and false, right? And like true, false, true and false, right? And when we have these three prepositions P, Q, R, so in that case we will have 8 combinations of true or false, because there are three symbols and three prepositions are two symbols, so it will be 2 cube 3, so 8 possibilities that we can form with these true and false. So what will be these? True, right? And true, false, right? True, false, true, then true, and this is false and false, like that. Okay, now we have false, true, false, true, false, true, and now we have false. So we have here the eight combinations, right? 1, 2, 3, 4, 5, 6, 7 and 8. So if you remember the tables for conjunction, disjunction, bidirectional, and if P then Q or implication, then you will be solve these, you can easily prove these equivalence as we know that these laws. So by taking these combinations you can prove these laws. So that's all for this video, and if you have any questions regarding this or any suggestions to improve these lectures, please let me know in the comment box, and I will wait for your suggestions if you watch these videos in totality or complete. So thank you very much. Thank you.